Today's lesson is about parallel lines and transversals. When we have two lines cut by a transversal, it means we have two lines such as these that are intersected by another line. Sometimes the two lines are parallel, sometimes they are not. First, we're going to discuss situations in which they are not. We can have alternate interior. This would be angle 3 paired with angle 6, and also angle 4 paired with angle 5. Alternate simply means that they are on opposite sides of the transversal. Consecutive means that they are on the same side. We also have something special called corresponding angles. These are angles that are sort of lined up in the same position. So for example, 1 would correspond with 5. So we have angle 1 and angle 5. We also have angle 2 and angle 6, angle 4 and angle 8, and angle 3 and angle 7. So as you can see, if I consider this to be the coordinate plane and I had 4 different quadrants, 1 and 5 go together, 2 and 6 go together, 3 and 7 go together, and 4 and 8 go together. I would like you to start by naming the vertices of this box using the following letters as shown in the diagram. Once you have done that, we're going to look at how some of these planes and segments intersect one another. The first question says, name all planes that are parallel to plane ABC. Plane ABC is this plane here at the top of the box. So what I'm interested in is what other plane is parallel to that plane. Keeping in mind that a plane is named by just 3 points, I am looking at the plane at the bottom of the box, which I could call plane TKG. I could really name it using any 3 of the 4 points. The second question says name all segments that intersect segment AB. This is segment AB right here. So I am looking at any segment that's going to intersect. That includes segment TA, DA, CA, CB, and also BK. C asks you to name all segments that are parallel to segment KG. So KG is this segment here at the bottom of the back of the box. Segments that would be parallel to this include the segments DA, BC, and TH. Notice that these are segments in the same plane, which are parallel, or in another parallel plane. D asks you to name all segments that are skew to TK. TK is this segment also on the bottom of the box. Remember, skew means that they are neither parallel or in the same plane. So skew segments are ones that will never intersect. So looking for segments skew to TK, I come up with DA, CA, DH, CG, and BC. So take a moment and jot those down. Considering some real-life situations, are the following situations intersecting, parallel, or skew? If I consider the shelves of a bookcase, those would be parallel planes. How about the sides of the Great Pyramid? Picture the pyramids of Egypt. There are planes that come together at a single point in the top, and they also intersect the bottom of the pyramid. So those planes would be intersecting. How about the path created by two planes flying at different altitudes in different directions? So you have to picture that they are not at the same altitude, therefore they are in different planes, because they're also going different directions. That would be an example of skew lines. The path created by two planes flying at different altitudes but in the same direction could be contained in a single plane, and therefore they would be parallel. We're now going to move on and talk about special situations of two parallel lines cut by a transversal. We will name all of these angles just as we did when we had two lines cut by a transversal. Making them parallel doesn't change any of the naming conventions. However, there are several postulates that are very important to know that we will use frequently in geometry. The first one states that if two parallel lines are cut by a transversal, then each pair of corresponding angles are congruent. So you may recall from the example above here that our corresponding angles would be angles such as angle 1 and angle 5. So we would state that they are congruent. Angle 2 becomes congruent to angle 6. Angle 3 is congruent to angle 7. And angle 4 is congruent to angle 8. Our next postulate says that alternate interior angles, if two parallel lines are cut by a transversal, then each pair of alternate interior angles are also congruent. And in our example above, this would pertain to the angles 3 and 6. So angle 3 is congruent to angle 6, and angle 4 is congruent to angle 5. I'm going to skip down to our fourth one, which says that if two parallel lines are cut by a transversal, then each pair of alternate exterior angles are congruent. So in our example above, we are now saying that angle 2 is congruent to angle 7, and angle 1 is congruent to angle 8. Take note that so far we've talked about 3 different types of pairs of angles, and all of them are congruent. The next one is a little bit different. Instead of being congruent, this one says that if two parallel lines are cut by a transversal, then each pair of consecutive interior angles is supplementary. not congruent, but supplementary. Remind yourself that supplementary means the sum of those two angles must equal 180 degrees. So we could write the statement that the measure of angle 3 plus the measure of angle 5 equals 180 degrees. The measure of angle 4 plus the measure of angle 6 also equals 180 degrees. The last theorem in this section says, in a plane, if a line is perpendicular to one of two parallel lines, then it is perpendicular to the other. So in this particular situation, I start with two lines that are parallel. So as you may recall, the symbol to show that two lines are parallel is like a little arrowhead on each of the two lines. According to this theorem, if this line, the transversal, is perpendicular to one of the two parallel lines, it is also perpendicular to the other.
Oops!